Hi everyone, good afternoon. We're going to hold this video to help you understand what are the important aspects about computing, especially for students and parents. So with me today, I am the Vice Dean of Undergraduate Studies, and we have a list of panelists here that will be able to address your questions. So we're going to start with my right and over to Seth.
Yeah, hi, my name is Seth Gilbert. I am currently the head of department for the Department of Computer Science.
Hi, I'm Anand. I'm the deputy head of the Department of Information Systems and Analytics.
Hi, I'm Sharon Tan, and I'm the Vice Dean for Industry Relations.
Hi, my name is Ansula Yao, and I'm the Assistant Dean of Research for AI.
I am Bimlesh. I'm Vice Dean for Student Life.
Hi, I'm Dongjun. I'm the current president of NUS Students Computing Club.
Great. So our first segment is going to talk about, real life issues. When we think about getting a job and the outcomes of computing, we hear a lot about the difficulties of jobs and how job titles matter a lot. Maybe we start with Seth. Seth, can you tell us a little bit about what you expect computing graduates to look forward to? Is it just the job title? Is there more than just that? Maybe you can double click on that for us. Yeah.
So the real goal of a degree in computing is to learn to think like a computer scientist, to learn how to solve problems using the tools of computer science, how to address real world challenges using computational ideas. Right? We want our students to graduate with a set of practical, useful skills. So when they arrive in the workforce, they can be immediately productive. We also want our students to have a deep fundamental understanding so that even as the world changes, even as new technologies evolve, even as tech stacks change, they can adapt and grow with the new technologies being developed. So our students don't end up all in the same place. They take a variety of different jobs when they graduate. Some end up as hardcore software developers. Some end up working in banks, doing quantitative finance. Some end up in biotech, adapting technological ideas to medicine and other biotech things. Some end up in the corporate world, helping to bring modern technology to business practices. Our students some end up in research in grad school and developing the next new big thing in computing. So our students do all sorts of different things when they graduate. And our goal then is they have the skills and background to be able to do what it is they want to do.
Sounds like computing is a really enabling degree, but I think a lot of people are also worried about exactly what type of coursework will you actually do, right? So the curriculum matters a lot. Can you help us unpack what's in a curriculum for a computing student?
Right. So the goal of our curriculum is really this balance between practical skills and foundational understanding. And all of our courses in some ways are designed around this dichotomy. So we certainly want students to graduate with a set of useful skills to develop software, to develop AI, to apply AI tools, et cetera. And we also want them to understand what they're doing, understand the underlying technology, and understand how these tools actually work. You see this from our foundational courses, where we'll teach algorithms and data structures and really, really foundational material. And then you'll see some of our courses where we're covering the hottest new cutting edge language models and whatever else is going on in the world that's exciting today. And so we want to hit both sides of things.
And Anand, I understand you have more to unpack about curriculum, so maybe you can help us understand from your point of view.
Sure. I think one of the important things that maybe incoming students don't realize is how we actually modify the curriculum. Our curriculum is not designed in isolation here on campus. We work together with people in the industry and an industry advisory committee to decide what we are going to teach, what kind of specializations we're going to offer. And these specializations, our degrees, our courses, the curriculum does get reviewed pretty often so that we're always keeping up with what's happening in the computing world, and so that our students can also keep up with what they're going to be seeing. But going back to what Seth was saying, I think the key thing is that we focus on principles that are a little bit more enduring, so that even when our students graduate, they know how to keep up when the technology world changes.
And one of the hidden secrets, I think, that goes beyond the specifics of the curriculum is just the amazing faculty we have. We have amazing instructors, amazing teachers who really know how to bring these things together, how to bring together both the fundamentals and the practical skills to create amazing courses. I think that's really our strength as a department.
So summarizing, we're leading the field, not following, but also being able to make sure we have solid fundamentals. I think that's what we're seeing both through the coursework, but also in terms of the faculty being very good teachers. So, I mean, these are all good for curriculum, but a lot of people are also worried about jobs, right? The aspect of, finding a real world experience. I mean, a lot of times we hear complaints that academics are out of touch, right? We're not in sync with what's going on in the real world. So, Sharon, you're the right person to answer this question, right? So, what does it mean for computing and industrial relations to mesh together?
So actually in SOC, we value industry exposure a lot. In fact, we embed industry exposure into our curriculum. So for all our students across all degree programs, they have a requirement to have this industry experience. And many of our students will take part in at least one computing related internship, typically in their third or fourth year before graduating. They can also embark on industry type of research projects if they are interested in that. And industry experience or industry exposure is not just only in terms of internships. They can start as early as in the classroom. So in the classroom, we have lecturers who bring in guest speakers. We have industry seminars where we involved our industry practitioners to come in and give workshops, talk to our students about what's happening in industry, what is relevant in industry. Our students also embark on capstone projects, and we invite our industry to provide real world problems for students to solve, where they actually work on real world data. They develop solutions, they interact with real stakeholders, they implement solutions that are actually being deployed and used. So our students get a lot of exposure, not just in the classroom, outside of classroom. In fact, even in terms of hackathons, we have industry practitioners coming in to propose and define business problems and also serve as judges for our students. So that's really a lot of exposure for our students. And I think in terms of that, they can use their experience to decide, what kind of domains are they more interested in, what kind of job roles are they more interested in, and find a fit for themselves when they look for their jobs.
Wow. I mean, I wish I had this type of schooling. I remember sitting there and taking notes with a chalkboard and transparencies. Many of us have been there before, right? So I think one of the key things about this experience is, even with all of these things that are integrated and dynamic, it sounds like a very fun place to be. Well, what is the value of a computing student? I mean, if you're all fun and games, do employers really think that, our students carry value? What does it mean?
I mean, I think a lot of the responses or the kind of feedback we've been hearing from industry is our students are very technically strong. So they also are very fast learners. They can adapt to, as we know that in tech industry, for example, there are a lot of new skills, programming languages will change as we go along. And but our students have very strong fundamentals, so they can learn very fast and they're very open-minded. So, if they see a problem that requires new approaches, they will try it out, they will learn it on their own and try it and solve the problem better. And then in addition to that, I think we also hear the industry feedback to us that our students are very independent. They always take a lot of initiative. And in some cases, we've heard of students, even though they are interns, they're helping to manage a project or manage a group of interns.
Right. So I see that there's a lot of real world impact from our students. So, I mean, with all we heard from the industry response, there's also another side of SOC where we have students who want to go on to do research work, because after all, we are one of the leading schools in computing, and that means research must be a big component. And I think a very good person to ask about the research and how SOC is doing all of these wonderful things would be Angela. So Angela, can you help us understand more about research in SOC? What does it mean?
Certainly. So at SOC, we actually have a broad range of research areas. They vary from systems and networking to security and programming languages, perception and robotics, AI and machine learning, human-computer interaction, and of course, a lot of interdisciplinary topics as well. And this research actually is not done in isolation just by ourselves. We actually do this in collaboration with many other partners, whether it's government partners or industry collaborators, and also other research collaborators in other faculties and disciplines as well.
Okay. Yeah. So, I mean, our parents and students are also interested, like, what are the opportunities for students? As an undergraduate, being in this great school of computing, are there actually opportunities for students to learn how to do research or experience research firsthand?
Absolutely. I think for students coming in, they can get exposed to research from day one already.
Mm.
For our undergraduates, they might get exposure to research through their individual coursework, also through programs like Europe, and then a little bit later on through their final year projects or FYP projects. So there's lots of opportunities to work into research as they progress throughout their education.
Yeah, and really, it feels to me like I always tell students that that's one of the unique opportunities here as an undergrad. One of the reasons to come to a university like NUS is there's so much exciting research happening. So many faculty here working at the cutting edge of their fields, doing the hottest, newest, most exciting things that have never been done before. And here, if you come here as a student, you have the opportunity to get involved with that. You have the opportunity to sort of sit right by the edge, see exactly what's happening, participate. Develop new ideas, publish papers, and so on. And so I really encourage our students to get involved in research, since I think it's one of the real unique opportunities they have being at a place like NUS.
Yeah, I think that's a really important point, right? Being at the edge of where things are happening, and computing being at the edge at where things are happening, you're double advanced in the sense that you're really at the bleeding edge, but in a very good way, right? Because we're experiencing change, and we are basically having our graduates shape the world rather than be shaped by the world. So there's a lot of agency for students to really do more with that. So
We actually have a lot of research pathways set out for undergrad students. Starting at the end of year one, they can take a DC program where they can interact with PhD students in different labs. And we also have a very well curated tutoring program for them, which they can do it like as a special program through their 4 years. Yeah.
You're the right person to ask about the next part, which is, we've talked a lot about research and academics and jobs, but, there's more to life than academics, right? So Bimlesh, as the Vice Dean of Student Life, maybe you can help us unpack, is SLC all that's made out to be, just about labs, tutorials, and tons of lectures that are nonstop? I mean, I just came from lecture myself. It's 3 hours and the students are drained after like week one. Yeah.
No, we have actually lots of activities going on. There are many student groups here, from hackers to grey hats to start it, you name it, AI society. We actually have a student representative who is going to share more later. So students do these events and learn together. Basically, we create these spaces for them. It's not that they are just learning in the classroom, but even beyond the classroom. So we have a lot of hackathons going on. Even this week we have one coming up, Hack and Roll. And later in the month we have another one, which is by the developer group for Hack for Good. Yeah. So we have many such events going on.
Right. And I think student groups are a good way to seg into our final participant here. So Dongjin, I understand you are a student leader and participant. Can you tell us, from your perspective, you have unfortunately a panel of profs here, right? No bros, but can you help us unpack whether it makes how's the life balance in SOC actually? Don't hold back. Yeah. Please go ahead. Yeah.
Okay, so I do agree that the curriculum is very rigorous, and of course, I think it's necessary for us to develop basic technical competencies that we would need in the workforce. However, outside of that, I feel it really depends on yourself to really make the most out of it or to do something with it. I feel, from my experience, I feel that university actually offers a lot of flexibility. After all, although not advised, but you can skip lectures and watch the recordings. Those are options that are available to you. Yeah, and I feel that when you join external societies and programs, it's really, that's where you can go and find your own people. And this is when your school life becomes less monotonous, not just lectures, tutorials, recitations, so on and so forth. Yeah, that's where you actually develop interest in future jobs, future careers. And personally, through Computing Club, I've met a lot of seniors, heard about their internship experiences, and that really broadened my horizons. And I think I used to be very bottlenecked in the sense that I thought that studying CS means I have to do software development. But from talking to seniors, I learned that, oh, you can do product management, you can do maybe AI engineer. And I feel that, yeah, you could do all these things. And through this, you would, I guess, develop as a person, and also, yeah, you can develop as a person on top of developing your technical skills.
Right. So, I mean, unpacking all of that and giving advice to, let's say, for example, parents. Okay, I'm ad-libbing here, right? So, are there advice that you can give to parents to say why should your child think about computing as well?
I see. I think for parents, what I would say is that computing itself is a very diverse degree, and even within SOC, we have a multitude of different majors that one can pursue. So, and like there's also quite a decent amount of flexibility when changing between majors. And so I feel if like for a parent, if like your child likes maybe coding and whatnot, they could join SOC first, and as they find out what they want to do through the curriculum and through interest groups, then they can maybe adjust their pathway, their education pathway, and their internship opportunities to align with that vision. Yeah.
Okay, so now we're going to go to the open panel. So we have one question to round out everything. Like if there was one message you really wanted to let students and parents really know that they should take away from their experience, what would it be? Yeah, so we'll open it up to the floor. Anyone would like to take this on?
Yeah. So, I mean, I think that, from what you've heard, you've been hearing lots about our department and our school. And I really think the bottom line message here is that NUS is an amazing place to study computing. And as I said earlier, I think the sort of hidden secret there is that we have an amazing faculty of amazing teachers who put a huge amount of effort into helping the students to develop their skills, develop their interests, and figure out where they want to go. And I think that's the real unique strength of our school.
So computing is a mindset, and it's a way of pursuing and solving problems and not just coding. And I welcome everyone to come and find out more about it.
I just want to say that SOC, NUS is actually a very vibrant campus, a very vibrant environment. So beyond the student activities we have in our school, there are also a lot of activities you can take part in within the campus itself, whether it's sports, arts, residential activities. So there's a lot of opportunities, not just developing yourself in terms of curriculum, academic skills, but really in terms of communication skills, leadership skills, and interpersonal skills. So, yeah.
I would like to add that we totally believe in that it's not being perfect on a particular day, but it's all about showing up and doing things together. So students are never in isolation. They don't learn in isolation. They don't work in isolation. It's always SOC is like a community, a family together.
I think one thing that it's common for students to worry about during our open house or open day is, I don't know if I want to do computing. I don't know if this is really what I want to be in, but the skills that you learn here are really very transferable across all types of industries and jobs. Even if you were to do research work here, or some of the research programs that Angela was talking about, they're all very transferable to job skills, right? So whatever you learn here becomes critical thinking skills that you are going to build upon for the rest of your life.
And it's quite fitting.
Oh.
We have Shindong as the last
Yeah.
participant. Yes, go ahead.
So what I'll tell like prospective students is that a computing degree isn't just a technical degree. It really depends what you make out of it. As our Vice Dean has shared, there's also NUS is a very vibrant campus. You can find your community in SOC or outside of it, and through that you would, I guess, discover that like uni isn't that monotonous, isn't that boring, and just have fun while you expand your competencies and skills.
Great. So I think we have a great panel today, and I think as a summary, I'd like to say, you could go with many different degrees, but why don't you consider the degree at School of Computing? Because again, we have one of the best research facilities in all of Asia and the world. You get to be with the best students, have the best exposure and a variety of curriculum and opportunities. I think you want to be in an environment where you can thrive and do even better than you could on your own. So with that, I think we've come to the end of our fireside chat, and I want to thank all of you for your participation today.